All right, hi. Continuing Track Safety Standards Compliance, Chapter 5, Class 1 through 5, April 1st, 2007. Although this one is dated 2012, they put different sections in there. Like, each different chapters were created at different times. We're on Chapter 5, Class 1 through 5, 213, 121, Rail Joints. 121A. Each rail joint, insulated joint, compromised of the joint shall be structurally sound design dimension for the rail of which is applied. Guidance proper to railroad to transfer the occurred rail joints must contact the head base of the rails when bolts are tight. Many rail joints designs have been used to the varying degree of success. The track safety standard does not attempt to single out any particular design as any only acceptable joint. This could inhibit innovation of the practice modern track design. The track safety standards require the structural soundness of the bolt condition and based on a maximum authorized train speed. Inspectors must attentively locate from the standard joint bars that are used with a similar device, similar rail sections where it would be proper to have compromised bars. The track safety standard recognizes the important aspect of the rail joints, beginning with the section requirement that the rail joints have structurally sound design and dimension rail on which they are applied. Rail joints are considered the necessary discontinuity that require special attention from the required railroad maintenance personnel, railroad inspector. The FRA inspection, as far as possible, a rail joint should provide the same relative strength, stiffness, flexibility, and uniformity as the rail itself. Figure 21 illustrates the proper application of the compromise of the joints. Alright, this is figure 21 that shows the compromise of the rail joints. Your left hand gauge, right hand out hand, left hand out hand, face of the joint between the determine the hand 140 RE rail. As shown in Figure 22, one of the design elements of the joint bars to consider is in the head contact of the head-free design. The head contact bar supports the rail end of the box type of construction, carrying the load between the underside of the head and base of the rail. The head-free joint bar does not contact the underside of the rail, and heads are instead contact the rail in the fillet area. The loaded distribution is referred to the triangular load distribution. Alright, figure 22 shows the head contact, it's a box type distribution. Head free shows the triangular distribution of your joint. So underneath the web and then on the side of the head. So usually the standard of the joint bar head contact design rail section other than the design but not may constitute deviation. The difference between the head contact joint bar and the head free joint bar are significant, and it is evident that the joint bar of the rail does not bend or flex exactly while the others along their length. Test measurements show that the positive bending there exists with the downward bearing pressure on the underside of the head of the rail. The top surface of the joint bars from some distance along the bar a while away from the rail ends approximately 2 inches. There is also upward bearing pressure the upper surface of the base of the rails as part of the length of the bar farther away from the rail end. The bearing distance is approximately 3 inches, the converse to the true negative bending. The head-free joint bar accepts the bearing share of the force of the vertical loads of the rail upper fillet. The head contact is not designed to fit the fillet, specifically the head contact joint bar except the bearing of the vertical loads on the flat underside with the rail head generally 1 to 4 slope. It is designed to seat the rail upper fillet, and although the vertical fishing dimension of 125 and 115 RE rail sections is indicated with the 3 by 3/16 of an inch for the head fillet radius is indifferent. For a 15-pound section, the radius is equal to 3/4 of an inch. For a 112-pound section, the radius is equal to 3/8 of an inch. As shown in Figure 23, the 115 head-free bar fits the 112 rail fillet practically, and its point must be properly inducing the joint bar stress and excessive design, which is the deviation of Pisachi 213-121A. The 112 head at contact with the bar does properly not fit with the 115 rail, as in bears the very small areas beneath the head of the rail, possibly inducing joint bar stress and excessive design, exerting the wedge action between the rail head and the rail web, promoting head and web separation. In addition, with the joint bar may experience the twist and torsional force of the tightening of the track bolts while used as in compromise in is compromised in 115 and 112 rail. The torsion stress from the twisting of the greatest at the head and the toe of the bar at the rail ends. The contact of stress on the 115 foot free joint bar with 133/8 of an inch radius and 3/4 of an inch radius on the 115 inch bar head contact joint bar. These exemptions are used if the joint bar head contact design is a real significant section other than the design. For example, the 131 pound bar and 132 pound head contact joint bar may be either used to either in lieu of 131, 132, 131, 136 compromising joint bar. If rail drilling joint bar punching is the same, the width of the railhead of the configuration is sufficient to allow the full contact of the upper fishing wear. In the summary, 112 pound, I guess that's Reading joint bar should not be used in compromising the joint bars between 112 Reading and 152 Reading rail. 115 pound Reading rail joint bar should not be used to compromise joint bar between 112 Reading and 115 Reading rail. 131 Reading contact bars and 132 head contact bars may be used to compromise the joint bars between 131 Reading and 122 Reading rail. The 136 Reading rail rail drilling and joint bar punching. On the same note, that the FRA standard does not prohibit the track owner from the field drilling of the bolt holes to fit. While above the dress compromise the joint bars is stressed in the statute. Is stressed in 112 Reading bars are not to be used in 115 Reading bars or in 119 Reading rail. Vice versa, the joint bars of 131 Reading rail head free of 132 Reading rail head free design. 131 rail head free and 136 head free joint bars is not interchangeable or not intermixed. For compodium of the rail section dimension in order to compare with the rail section compatibility between the joint bars and various rail sections for the appendix C of this manual. 121B, if the joint bar of class 3 and 5 of the track is cracked, broken because of the wear, allows the excessive vertical movement of either the rail or when all the points are tightened, it shall be replaced. Again, joint bars are designed to fit in the space between the bottom of the railhead and the rail base to fishing. The bolt tights of the joint bars are wedged with the fishing space that provided with lateral vertical beam strength through their supporting the abutting rail ends. Whether they head up against the rail bolts, the joint bars can contact the rail at the 2 points bottom of the rail head or the fillet at the top of the rail base. The contact the point was known as the fishing surface can experience metal loss due to the abrasion mechanical wear of the curves during the silical training dynamic loading. After long-term service, the fishing surface over the rails of the bars can either wear to the point of the joint of the bars no longer the wedge into the rail, even though the tight bolts, and in such a case the joint assembly will no longer optimally support the abutting rail ends. Joints minimally the worn fishing surface can provide with the safe passage of the wheels in class 1 through 5 is guided with excessive vertical movement with exists whether there is significant fishing surface wear or wear loads causing the abutting of the rail ends existing the tread mismatch appropriation the thresholds under statute 213-115 the excessive vertical movement that occurs therefore there and any of the cracks corrective action will be to replace the bars to take other corrective action. Proper corrective action of a joint bar cracked or broken other than the center break in classes 3 through 5 would replace the reduction to a class 2, and if the both joint or bolts are cracked and broken between first and second bolt hole, including through the second bolt hole, it should be considered a class 1. This is because there is only one bolt in the rail end that is within the remaining section of the joint bar that is providing support. Alright, 121C, if the joint bar is cracked or broken between the middle of the two bolt holes, it should be replaced. Guidance, the center crack of the broken board is appropriate with corrective action or replacement of the reduction class 1 speeds under the provision statute 213-9B. 121D. In the case of the conventional jointed track, each of the rails should be bolted with at least 2 bolts in each of the joint in class 2 through 5, with at least 1 bolt in class 1 track. The guidance: the track owners must have the number of the required bolts in each of the rail of the joint. The paragraph does not prescribe the tightness of the torque standard for each of the bolt. The bolt no longer can be support the joint bar against the rail. Will continue to provide resistance to pull the parts of the railing section in tension. The ability to bolt to the holders against the rail to support the abutting rail ends is covered in statute 213-121F. If the bolt does not fulfill the requirement of the paragraph, is an intermediate danger component failure and is no longer holding the bar to the rail and no longer resistant to pull the part and forces. For example, the nut is missing and it would likely fall off under the subsequent train movements, or the ball shaft is fractured. 121E. In the case of continuous welded rail track, each of the rail shall be bolted with at least 2 bolts at each joint. Guidance: rail length is more than 400 feet. Continuous welded rail. Purposely applying the requirements of the paragraph. If there's only 1 bolt in the rail end of the joint of the continuous welded rail, stringent 400 feet longer, the 1 bolt will be subject to all tensional axial forces while easily shear and break, resulting in the pull apart. 121F. Each of the joint bars shall have held in position with the track bolts tightened, allowed to the joint bar to firmly support the abutting of the rail ends, allowing the longitudinal movement of the rail into the joint, accommodating the expansion contracting due to the temperature variation, with no slip of the joint rail contact. The existing designs requirements of the paragraph do not apply. Those locations, when over the 400 feet in length, are considered to be continuous welded rail track and shall meet all the requirements of the continuous welded track as prescribed in this part. Guidance: if those joints are loose, if the joint is not in compliance with the statute 213, 125, 121F, and the addition with the joint assembly in non-compliance with the adequate tightened bolts and preventing it from supporting and abutting rail ends of unexpected traffic loads. Joint bolts can deteriorate sufficiently to create condition when the bars become completely detached with the rail, causing a total lack of support, which contributed to a broken rail. And such condition can create a mismatch with exceeding with the limits specified in statute 213-115. Rail end mismatch. In such case, the defective wood rail, the mismatch and class specific, the inspector should include the notation on the loose joint bars. The paragraph also recognizes the design characteristics that enable the rail end joints to move longitudinal to handle temperature changes, the expanded contraction of the rail, creep the track of the flowage. The type of the joint bar assembling in the standard of the joint, because of the type of the track and construction, has lower axle forces than the continuous welded rail. In the continuous welded rail, it is desired to contain the rail expansion contraction in the remaining joints, insulated joints, in order to eliminate the pull-apart action that occurs with the rail regular joints. The continuous welded rail, the track structure by the design dissipates, but the axle load forces, according with the paragraph, allowing the joint design to stop the axle rail movement with the assembly. Except the axle movement component with the paragraph, the joint bars are glued installed, and joint bars are subject to all maintaining requirements of the paragraph. All other paragraphs of statute 213, 121, the types of assembly are considered to be joints, even in continuous welded rail. See statute 213, 119. However, the definition as continuous welded rail, glued joints and non-longitudinal discontinuity in a rail string. The glued joints are also considered joints under statute 213, 109 with respect to required position of non-defective ties joints. 121G. The no rail shall have the bolt hole in which torch, cut, burn in class 2 through 5 track. Guidance: the paragraph prohibits the use of the rail containing the bolt hole that has been torch, cut, burned in class 2 through 5 track. 121H. No joint bar shall be configured with the torch cutting of the class 3 through 5 track. Guidance: the paragraph prohibits the reconfiguration joint bar cutting of the class 3-5 by omission of reference to class 1 track. This practice configuration is allowed in those classes, however, the joint bars are reconfigured by torching cutting. These must make certain the criteria for the structural soundness and design dimension which is required in under A section. 213, 122 torch cut rail. 122A. Except for the temporary repair of the emergency situation, no having of the torch cut or shall be used in class 3 or 5 track. Whenever the rail end torch cut is emergency situation, train speeds over the rail end shall not exceed maximum allowable class 2 track. For existing torch rail ends, the class 3 and 5 track shall follow the applying. Within 1 year of September 21st, 1998, all torch cut rail ends of the Class 5 track shall be removed. Within 2 years of September 21st, 1998, all torch cut rail ends of the Class 4 track shall be removed. Within 1 year of September 21st, 1998, all torch cut rail ends in Class 3 track over the regular scheduled passenger trains operate shall be inventoried by the track owner. Guidance: the regulation prohibits the torch cutting of the rail ends of the Class 3 through 5 track except for the temporary repair in emergency situation. In such emergency situation, the train speed shall not exceed a maximal allowable for Class 2 track. Existing torch cuts must be removed from the track following the time frames: Class 5 track September 1st, 1999, Class 4 track September 2000. 21st, 2000. Class 3 track with passenger, and by September 21st, 1999, all torch cuts shall be inventoried by the track owner. 122B. The following is expiration of the time limit specified in A, 1, 2, and 3. Of this section, any torch cut but not removed from the Class 4 and 5 track. Any torch can cut rail end not inventoried by the Class 3 track over the regularly scheduled passenger train operation shall be removed in 30 days of the discovery. Train speed over the rail end shall not exceed maximum allowable for the Class 2 until removed. Guidance: the torch cut inventoried with the grandfather in any of the torch cuts found in the expiration 1 year of the not inventoried with the slow order but the Class 2 removed within 30 days of the discovery. If the railroad chooses to upgrade the segments to track Class 3 passenger train operated with all torch cuts must be removed by 4 speeds and exceed the maximum of Class 2 truck. If the railroad chooses to upgrade the segment of the track from a lower class from 4 to 5, it must remove all the torch cut. Alright. 213, 123 tie plates. 213, 123 class 3 through 5 track when timber cross lakes are in use, they must be in tie plates under the running of the rails at least 8 of 10 consecutive ties. 123, the class 3 and 5 note metal object will cause the concentrated load solely supporting the rail shall be allowed between the base of the rail and the bearing of the surface of the tie plate in the paragraph that is applicable in September 21st, 2099. Guidance, the inspector should consider the section jointly with requirements for the cross tie of the rail fastening, the report of the tie, the condition of the rail defect as defects and safely is impaired with the absence of the tie plate. In classes 3 through 5, the track no metal that causes the concentrated load and solely supporting the rail shall be allowed between the base of the rail bearing the surface of the tie plate. The specific reference of the metal objects intended will include but only items of the track material with the greatest potential for the broken base rails for such a track space. Spikes, rail anchors should be the tie plates of the phase of the curve of the concentrated load and solely supporting the rail. Further clarifies the intended with the regulation to apply only in the instances where there is clearly physical evidence of the metal objects and placing the substantial load on the rail base as indicated with the lack of loading in adjacent ties. Alright, 213, 127, rail fastening system. The track shall be fastened by a system of components effectively maintaining the gauge within the limits prescribed in Statute 213.53b. Each component of each such system shall be evaluated to determine whether the gauge is effective in being manufactured or maintained. Guidance, rail fastening system included modern data elastic fastening system, which consists of abrasion bands and insulator clip. Should insert the cast to the concrete ties as well as the fastener itself, and should its different design are used today. The fastening system can also be a traditional cut and spike variety with or without tie plates. The failure of certain critical components of a particular system could adversely affect the ability of the individual fastener to provide adequate gauge and resistance. The wording of the regulation provides for the evaluation of all components within the system as necessary with the degraduation of fastening system has resulted in problems maintaining gauge within the limits prescribed in Statute 213.53b. When the inspector identifies the gauge geometry condition with the fastener system has the degraded location of question system meets the factors described below, the inspector must examine the component of the fastener system, clip, insulation, pan, bolt, spiking, pattern, etc. The inspector should describe the nature of the failed component on the Form 96 form. Is the fastener condition causing the grades to exceed the limits of Statute 213.53, the inspector should report the condition of the gauge defect and describe the nature of the fastener condition of the same defect or line report. The section requires the inspector to exercise the judgment, evaluation, condition, fastener, and the following factors should be considered in the elevation gauge exceeding the limits of 213.53. In such cases, the track class gauge of the governing gauge close limits to Statute 213.53 with evidence of recent widening, evidence of the recent rapid deterioration of gauge with a probable condition of deterioration, evidence recent significant damage to the rail fastener to the extent of the gauge widening is probable, evidence recent maintenance work improperly performed and resulting in lack of efficient fastener to prevent gauge widening and unexpected traffic conditions including speed, tonnage, and type of equipment, conditions, the curvature, and grades. The FRA inspector may make a portable track loading fixture as described in Statute 213.110 for the purposes of measuring effective fasteners, referring to Appendix E for the portable track loading fixture, instructions for gauge resistant measurement system territory Statute 213.53. A unique attribute to the concrete ties is the abrasion can occur between the base of the rail and the rail seat of the cross tie as a component with the rail fastening system. A variety of padded design materials are placed on the rail and ties mitigated with the abrasion. However, the equal unaided wedged in the abrasion with the rail seated with the problematic for the high speed of the high tonnage operating environmental that may cause the rail fastener to become loose or underloaded with extreme cause the rail tilt and roll out. See Figure 24. Accordingly, inspectors should locate the rolled out due to the rail seat abrasion on the concrete cross ties, particularly the territory and heavy traffic levels, moderate curve, the mechanics of the condition, concrete cross ties, including the following elements: concrete wear abrasion resulting from the loose of the rail clips, insulators, pads, and loosening components, allowing the moisture abrasive to enter the rail seat. Once the field side of the rail base, where the tie pad contacts the concrete with the rail seat, and the rapid cutting of the concrete, accelerated abrasion can occur. Figure 24 shows the concrete cross tie with the rail seat abrasion, the rail resilient fastener, the resulting force, the rollout, the vertical force, and the lateral force. Signs and symptoms of concrete cross tie rail seating abrasion include tie pad crush and squeeze, maintain integrity of the tie pad, essentially insulator crush and moving the missing clip, losing, indicating loss of pressure on the rail base, loss of the toe load. Longitudinal rail movement indicates the cemented color paste and ballast of the braids with the rail seat, medical flaking, and grease streaks in the center of the low rail and curve caused by the outer rim of the wheel. False flanges, placing excessive pressure on the head of the rail in condition generally created by the gauge widening. Based on the above discussion, the impairment with the rail seat abrasion concrete caused the rollout. As the rollout occurs, the decreased effectiveness of the rail fastener and will often lead to gauge geometry conditions. As general rule, inspectors should cite the condition of the rail fastener and defects. Defective code statute 213-127-02. However, the railroad rollout caused the gauge to exceed the threshold designated in the class of the track. Inspectors should cite the condition as a gauge defect in statute 213-53. Rail anchors are not considered rail fastenings. Resilient rail fastening, the more performed dually function resistant rail for laterally and longitude should only be evaluated on their ability to provide lateral restraint to prevent gauge widening in regarding this section. An insufficient fastener defect was written when unsafe condition results from the missing defective fasteners, heads and cut and spikes shredded off a throat and otherwise supportive cross ties.